We have felt the problem. Now let's define what a queue really is and find a layout that reuses those wasted cells. So here is where it hurts. Every DQ moves front one step to the right. The cells before front are stranded. You can never reach them again. Meanwhile, rear can only move to the right. It keeps needing new cells on the right, even while the array has free room on the left. In the end, rear reaches the last cell and cannot advance. So a linear array, Q, loses capacity every time it dequeues. We need a layout that reuses the freed cells instead of throwing them away. Take an array with capacity 6. Front is the next slot to read, and rear is the next slot to write. This is a linear queue, so rear never wraps back. Let's trace it, one operation per row. In Q10, we write 10 at rear, which is index 0, then move rear to 1. Count is now 1, and the contents are just 10. In Q20, we write at index 1, then rear moves to 2. Count is 2. In Q30, rear moves to 3. Count is 3. In Q40, rear moves to 4. Now count is 4, and all 4 values are in the queue. Front is still 0 the whole time. Now DQ. We read 10 at front, then move front to 1. Count drops to 3. Index 0 is now behind front, so it is wasted. DQ again. We read 20 and front moves to 2. Count is 2 now, and index 0 and index 1 are both wasted. Here is the final layout. Front is at index 2, rear is at index 4. 2 live values, 30 and 40. 2 wasted cells on the left and 2 free cells on the right. Now the trap. 2 more in queues, 50 and 60, fill index 4 and index 5. Then rear reaches 6 and cannot advance. The array reports full, even though 2 empty cells sit at the start. A linear queue always reports full in the end, no matter how much you dequeued. Now the fix. We treat the array as a ring. After the last index, the next slot is index 0 again. Rear moves with rear plus 1 mod capacity, so it wraps into the cells a DQ just freed instead of running off the end. These 2 cells at the start, index 0 and index 1, are free again. On a ring, they are reusable. The ring never runs off the end, so indices 4, 5, then 0 and 1 are all still usable. The rule is one short formula. The next rear is rear plus 1 mod capacity. Try it at the last index. Index 5 successor is 5 plus 1 mod 6, which is 0. The ring closes on itself, and every freed cell gets reused. So a circular buffer is an array whose index math wraps with mod capacity. It acts like a ring, but in memory it is still one contiguous block. One thing to watch. You may read rear plus 1 as the next slot, but at the last index that runs off the end of the array. Taking mod capacity brings it back to 0, so the ring never falls off its own edge. A queue names only 2 positions. Front is the next element to read. Rear is the next slot to write. You can build a queue 2 ways. The first way is a circular array. Front sits at index 0, holding 10, the oldest element. That is the next value we would read. Rear sits at index 3, the next empty slot. That is where the next value would be written. The 3 live values are 10, 20, and 30. The indices wrap with mod capacity, and the capacity is fixed. The second way is a linked list, with 1 node for each element. Here 2 pointers, front and rear, aim into the chain of nodes. In a linked queue, rear points right at the last node. This version grows without a fixed capacity.